You are in room Lagoon K, and you are here to see, make sure I get it right here, Paul Stone and Alex Chapman, and their talk, WSUSpect, Compromising the Windows Enterprise via Windows Update. I'll turn it over to you, gentlemen.
Thank you. Hello, can everyone hear me all right? Yep, good. Okay, I'll make a start then. So we're going to be talking about Windows Update, and the kind of focus of our talk is Windows Update in kind of an enterprise scenario. So just a kind of brief overview of what we're going to be looking at. So first of all, we're going to just talk a bit about why we decided to look at Windows Update. We're going to explore some of the attack surface of Windows Update, the things we might be able to do with it. Then we're going to talk about drivers, look at what drivers are available via Windows Update, and then we're going to move on to WSUS, which is the enterprise variant of Windows Update. So we're going to delve into WSUS. I'm going to talk a bit about how to compromise it in certain situations, and because we like to be responsible, we're going to tell you how to fix those problems as well. So just brief introductions. Well, I guess we've already been introduced, but I'm Paul, this is Alex. We both are researchers. We work for Context Information Security. We're based in the UK. So, first question, why look at Windows Update? Well, one question we had, which apparently lots of people share the same question, is why is it so damn slow? But more seriously, from a security perspective, why are we looking at Windows Update? Well, one of the interesting things about Windows Update is it's a very privileged service. So updates can be downloaded and installed by normal users, by non-privileged users. So there's potential there, potential for elevation of privilege vulnerabilities. The other thing about Windows Update is it both increases and decreases the Windows attack surface. So in the sense that it downloads and runs codes over the internet, which can be a dangerous thing to do if it's not done properly. And obviously, it's a necessary thing. So, every software, all software needs patching, and Windows Update lets Windows patch itself against vulnerabilities and other bugs and so on. And the other interesting thing about Windows Update, the thing which kind of really piqued our interests to start with, is that not only is there Microsoft code available via Windows Update, but there is also a lot of third-party code, notably in drivers. So with drivers, we're talking about code running in the kernel and other privileged stuff going on. So these are good reasons to look at Windows Update. And finally, it seems that very few people have actually looked at Windows Update in the past. We couldn't find that much kind of research on it out there, so we thought we would have a look. Okay, so just a kind of brief overview of the various different components of Windows Update. So Windows Update is a Windows service that runs. There's an executable called WUAUCLT. I have no idea what it stands for, but that's a thing that runs periodically and actually checks for updates, contacts the Microsoft servers to see if there's anything, downloads, updates, and so on. There's a whole bunch of registry keys which control things like how often updates are checked for, when they get applied, what server to talk to, and so on. And the actual protocol itself, the way that your computer talks to Microsoft servers, so that's actually a SOAP web service that goes over HTTPS, and we're going to take a look at that in detail later on. There's a local database that keeps track of what updates you've installed and so on, and there's this C Windows software distribution. That's where a lot of the stuff happens, so updates get downloaded and extracted there and so on. And also, if you're kind of looking into this area, doing the research in this area, the Windows Update.log, that's really useful because that shows you what's going on in the background. So these are the kind of things that we were looking at the start. So just briefly, what stuff is there on Windows Update? So obviously there are security updates, there's critical updates, and I guess less critical security updates. And there's a whole bunch of other stuff, just general software updates, things like updates to Internet Explorer and Office and so on. But the thing that kind of caught our eye early on is drivers. So I'm going to hand over to Alex to talk about drivers.
Thank you, Paul. So, as Paul mentioned, why did hardware drivers actually appeal to us? So by default, when a new device is plugged into a Windows machine, Windows Update will actually go and download and install the drivers and associated software for that bit of hardware. So I don't know if some common ones like the NVIDIA control panel and that sort of thing actually come down as part of the Windows update. So the hardware vendors submit their code to be distributed by Microsoft. The drivers actually have to be signed by Microsoft, but actually, as Microsoft say in their signing guidelines for ISVs, the code quality is actually the responsibility of the vendor. So whilst they do some checks, they don't actually do rigorous checking of the code submitted to them. And any code that is submitted to them will actually be distributed via Windows Update. So that's really interesting. You've got third-party vendors submitting actually very highly privileged code. So we're talking kernel drivers here running in the core of the operating system to Microsoft, and we're supposed to trust them and the quality of their code to keep our operating system secure. So I guess we've all seen it. What actually happens when you plug in a new hardware device? So you plug it in. The plug-and-play service will detect that a new device has been added to the system and adds it to the Windows device tree. If the driver is recognized or the device is recognized and there's a driver available, the driver will be loaded and the device will communicate and work as expected from there. Where the device isn't recognized, the update service will send the entire device tree up to Windows Update, so that's every single device that's installed on the system. Windows Update then responds with a list of available packages and downloads and drivers, and then the update service will pick the most relevant, download that, and begin installation. I guess as alluded to earlier, so these driver packages do include other things than just drivers. So you'll get user applications, support applications, a number of Windows services, installation wizards, and other such software along with your required kernel driver. So these are the just a quick overview of the processes involved. So the update service running in SVC host there as a highly privileged user. That then hands off to drivinst.exe to actually do the full driver installation. So that will actually place the kernel driver in System 32. We can see the run DLL and DL notify there. That's running as the current user. So that's the user interface that pops up, say, Windows is searching for a new device driver for this bit of hardware, the device is being installed, etc., etc. And then in this case, there was an installation wizard that came along with this driver installation, and that's there, again, running as a low privilege user under run DLL 32 and newdev.exe. So that's kind of an overview of what happens when you plug in a device. How do we actually go about researching this? So Windows Update has drivers for a large number of types of devices. So graphics cards, bus controllers, network cards, all of these types of things will all trigger a Windows Update search and download the affected drivers, the required drivers. But installing these bits of hardware is actually quite slow. It's a very difficult thing to do on a large-scale basis. So we wanted to choose something that would be a bit easier and cheaper, primarily cheaper, for us to do. So we thought we'd look at the subset of drivers, USB device drivers. So how do we go about finding all the drivers on Windows Update? So the first thing we did, we emptied our drawers, pulled out all the USB devices we could find, started plugging them in and actually monitoring what's happening. My personal favourite there is the little doggo. I enjoy that one. But we ran out of devices quite quickly, and we only had the sort of devices you'd have around your normal office, apart from maybe the dog. So we set with a number of options. We could go and buy as many devices as we could find, but there's no guarantee we'll obviously find all the devices, costs start racking up, and there's a slow turnaround. So being hackers, what do we want to do? We want to automate this in some way, make it easier for ourselves. So our first thought was, right, brilliant. We've been playing around with face dancers and BeagleBones, all this sort of thing. We could use one of those to emulate USB device drivers and do things that way. Just brute force USB vendor IDs and product IDs, and we'll be done in actually quite a long time. And also, this doesn't parallelize well. These devices are quite expensive, so getting an array of 10 of them is going to start racking up the costs and actually not being all that quick. So it would be much better if we could search Windows Update. There's no search interface inside Windows, the operating system itself, so the operating system can only check for updates that apply to itself and its current hardware. So bit of a bust there. The WSUS local database does have some hardware drivers listed that aren't currently installed, but by no means all of them. So ideally what we want to do is be able to actually search the SOAP XML web interfaces. Fortunately, Microsoft do provide a web page to do this, so catalog.update.microsoft.com. I don't know if anyone remembers this. This is back from the XP era, and it actually, you can see. So its requirements are IE6 or above, and it actually requires the installation of an ActiveX control. We're talking that era of the web. But it does include all modern updates for all the modern OSs, so that's absolutely brilliant. So first steps, you go to the catalog with Firefox here, and you're told you need to use IE6. So we get our IE6 out, we connect, we install the ActiveX control like we're told, and we can then actually access the catalog interface and start searching for drivers. So this is going to make our life a lot easier, a lot quicker, and a lot cheaper. So in terms of USB device drivers, we can actually search on the USB vendor ID and product ID, which is really useful. Or we can just go blanket search for the USB vendor ID. So this allows us to find all device drivers for a particular vendor that are available on Windows Update. So that's kind of cut our work down from having a brute force vendor IDs and product IDs to purely vendor IDs. So we come up with a plan. So we get a list of vendor IDs. So these are actually published. Individual vendors are assigned individual vendor IDs. So we find one of the public lists, and we can use that. We're then going to scrape the Windows catalog for all USB products for each individual vendor. We're going to make a database of all the drivers, download them all, install them all, do something, and then profit. That's the way all good plans start. So we did this work back in April of this year. We created this database. Excuse me. So the results from the initial database scrape. So we identified 425 vendors that have updates on the Windows Update, 25,125 unique driver update GUIDs. That actually boils down to a much smaller number, only 4,600 unique downloads and download hashes. But still in there's a lot of duplicates and obsolete driver versions and things like that. So in the end, we whittled it down to 2,284 drivers for download. So set the downloads off going, came up with about 5 gigabytes worth of drivers for us to install. Fantastic. And these ranged in size from 100 to 150 megabytes down to just a few kilobytes each. So huge variety there. In this list, as we'd expect, there's a lot of standard devices. So printers, memory cards, Ethernet devices, etc., etc., etc. Lots of weird and wonderful sounding things. So my favorite there is the ST Microelectronics Intel Sensor Solution Blue Box DFU. Got no idea what that is, but it sounds cool. Display link adapter, so that's something that allows you to pipe VGA over USB 2. So some actually quite interesting devices there. A lot of the funkier sounding devices actually just ended up being USB to serial drivers, so a bit generic and less interesting. And some of the driver downloads actually just enabled built-in drivers, set a couple of registry keys, and did nothing else. So a bit of a variety there. So each of these downloads is a Microsoft CAB file, so it's basically just Microsoft's archive format, which can be signed, so all of them are signed. They contain the int file, which is the installation directives and supported hardware. So actually how it installs, what it then goes and installs, and then the files we'd expect. So the kernel drivers, DLLs, exes, help files. We saw quite a lot of things developers seem to have forgot to remove. So a lot of PDB symbol files were included along with the drivers and other files we wouldn't have expected there. So back to the plan. We've got our list of drivers. We've downloaded the ones we're interested in. We then need to install all the drivers. So I don't know about you, I've built quite a few Windows systems in my time. Installing drivers can take a very long time. I didn't want to sit there and do it manually with 2,284 drivers. So we're hackers. We want to find a way of automating this. So fortunately, Microsoft very kindly provide an application to do this. So the DevCon application, so the Windows Device Console, it's part of the driver development kit. This requires a high-privileged user, and I'll come back to that in a minute. But we can actually provide it with an int file and a cab file and a USB device ID. It'll take that. It'll then go and install that for us on the local system. So an example there, and then we get, obviously, the success or failure status of that installation. So we set this up, VirtualBox VMs, automating all from the command line. We bring up a VM snapshot. We launch DevCon via PSexec. We monitor the installation, so we take snapshots of the file system. We run procmon. We perform the installation, record changes. So again, changes to file systems, services installed, processes running, other interesting things like that. And we repeat this for every driver. So this, we've gone from our hardware solution or initial idea, done something that's actually highly parallelizable, and we can run it across as many virtual machines as we want to really speed this up. However, it's not a perfect solution. As I mentioned, DevCon actually has to be run as a high-privileged user. So the things we're trying to simulate here is actually a low-privileged user plugging in a physical USB device. And we're kind of 70% of the way there with DevCon, but it's not quite what we want. So we did run it this way. We collected some results, but then tried to improve our methodology. And this is where we stumbled across the Windows Device Simulation Framework. So this is, again, part of the driver development kit, but only in older versions. So the latest available version was in 7.1. It's since been discontinued in 8 and above. So this actually allows the simulation, full software simulation of USB devices. This sounds perfect what we want. Documentation is a bit thin on the ground, but it does come with some really useful scriptable example devices. So using VBS, we can actually create these devices and simulate them enough for our needs. So we acquire this, and then we set it up with our VirtualBox using USB filters to always pass through the simulated device to the VM guest. And this automatically triggers the plug-and-play service to identify the new hardware. And actually then we can automate this as a low-privileged user across all devices very, very easily. So at the end of this process, we attempted to install 2,284 USB drivers. Only about half of them, 1,150, installed successfully. Of those, only about 600 did anything actually interesting. So we ended up with 533 new kernel drivers. Admittedly, we didn't just do this on a single system. We had to do it across all of them, because that's a lot of drivers running on one system. 58 installed auto-run programs, so these either run at boot or when the user logs in. And 12 installed services running as high-privileged users. So I think we can say from our initial attack surface to running all of these installations, it's actually increased hugely. And remember, this is all third-party code. So I'm set up there. I'm thinking, right, brilliant. What I need to do next is create some automated disassembly, vulnerability finding system. I'll do this, and we'll find some fantastic results. Unfortunately, as with a lot of research, we hit two big roadblocks there. So the first one being time. That's a presentation in and of itself. But the more important one was actually scope. So whilst doing all of this, I'm doing it on standalone virtual machines that aren't connected to the network. And we suddenly thought, actually, will this work in an enterprise environment? Because that's the focus of our research. So we fired up a Windows 2012 domain, plugged it all in, WSUS, try and run this through WSUS, and it turns out, no, it won't work. So WSUS administrators have to specifically enable Windows drivers for installation. So in a default installation of WSUS, none of this will work. Great. So let's take a look at WSUS a little bit closer. So pass back to Paul.
Thank you. Okay, so we're going to do a deep dive into WSUS. So just a brief introduction. So WSUS is essentially the Windows Update software that you would normally connect to that's running on Microsoft servers, but you can install and run it on your own local server. It's pretty much the same, so it's the same SOAP XML web service. From the client point of view, it's almost identical. The big difference is for administrators. So the idea with WSUS is that it will go and download all the updates and cache them from Microsoft servers, and then it will distribute them out to all the machines in a sort of Windows network. And the benefits for administrators is that they can control when the updates go out, they can test updates and approve them, they can withhold certain updates and so on, and they have visibility of which machines have installed which updates, which machines hadn't rebooted yet, and so on. So let's talk a bit about the security of WSUS. So I tried this. We set up a Windows Server 2012 machine. WSUS is very simple to set up. There's a nice wizard. It takes about 10 minutes to run through. And at the end of that setup wizard, WSUS is up and running. Everything's working, and all it's left to do is just configure the client machines to connect to it instead of connecting to Windows Update. There's one slight problem, is that at the end of the wizard, SSL is not enabled. So this is the kind of default setup. You run through the wizard. There's no SSL for that SOAP web service. Now, to Microsoft's credit, the very first thing you see after completing the wizard is this screen down here. It says next steps. To fully configure your system, you should explore the following topics. And the very first link there is a link to using SSL with WSUS. So if you follow that link to the MSDN site, you get to a page that includes this text here. So it explains a bit about the security of it. So what it says is WSUS uses SSL for metadata only, not for update files. So the update files are always fetched over HTTP, and that's the same for Windows Update as well. It then goes on to say that actually the update files themselves are signed, and it uses hashes of the files as well. So when an update is downloaded, it says here, WSUS checks the digital signature and the hash, and if the update has been changed, then it doesn't install it. So essentially, if the updates have been tampered with in any way, then it's game over. And one really, really important thing is the updates, they have to be signed, but they have to be signed by Microsoft. So let's have a think now. Let's have a think about the potential attacks that we could do kind of within these parameters. So let's imagine that an administrator has not set up SSL for their WSUS installation. So if SSL was not being used, then potentially an attacker, a network-based attacker on the Windows network, could see the traffic, they could intercept the traffic, and they can modify it. But the updates themselves, we can't modify those. We're going to assume that we haven't got any crazy, signature bypasses or anything like that. So we can't modify the updates. So what can we do? So what we can do is we can modify the update metadata itself. So things we could do, maybe we could, if we could intercept the man in the middle of the traffic, we could prevent updates from being applied. So maybe we could prevent critical updates from being applied. It's fairly bad. We could perhaps go back to the driver stuff. We could force certain drivers to be installed, maybe third-party drivers, if we know there's a vulnerability in them, perhaps. Or we could even potentially do things like downgrade attacks, perhaps. We could, find a, if the machine's been patched against a recent O-Day, we could downgrade, find a previous update that kind of remove that protection, remove that update, and then go and attack a known vulnerability. So those are all possible things, but none of them really stand out to me as being particularly easy or particularly easy to kind of exploit across the board. So let's go and have a look at this SOAP web service in a bit more detail. I should warn anyone of a nervous disposition, we're going to be seeing a lot of XML in the next few slides. So we want to have a look at the WSUS traffic. We need to proxy it. So we can just use a normal proxy like burp. And if WSUS is using HTTPS, then the CA cert from your proxy, that has to go in the machine certificate store. That's opposed to normally you install your proxy cert in the user store, which is what IE uses, but for WSUS it has to be in the machine store. But honestly, it's probably just easier to do it without HTTPS. Just and not have to worry about that. Windows Update does respect the proxy settings. Sometimes you might have to restart the Windows Update service to get it to pick up the proxy settings, although normally not. So the main thing we're interested in is this, the endpoint, which is client.asmx, this one here. So this is where most of the interesting stuff happens. And the SOAP web service is actually documented on MSDN. Well, it's partially documented. Now, I'll show you why that's kind of interesting shortly. But there is some useful stuff there. So first of all, we're just going to have a look at the kind of sequence of SOAP calls that happen when Windows Update talks to the WSUS server. And this is largely similar to what happens with normal Windows Update if you're not using WSUS. So first of all, there's a bunch of calls which are used to set up the connection. And these normally just happen once. So there's get config, and it returns some config data. There's get authorization cookie, which goes to a different different endpoint called SimpleAuth. The important thing here is, although it says get authorization cookie, there's no real authentication going on here. There's no kind of Windows credentials going backwards and forwards, nothing like that. WSUS is pretty much kind of unauthenticated service. Anything can talk to it if it wants to. So the client gets this authorization cookie, it then exchanges it for another cookie. I don't know why. But this second cookie is really important because you need it for all the subsequent requests. You need that cookie. And then the computer registers itself. So essentially it says, this is the OS I'm running, this is my computer name, and so on, a few other details. And then the server associates those computer details with the cookie, and then from then on it knows what machine it's talking to. So all this normally happens just the once, unless the cookie expires or so, and these calls don't happen that often. So the really interesting stuff is what happens next. So what happens when a computer actually checks for updates? So first of all, there's a call to a method called sync updates. And with that, the client sends a list of all the update IDs that it's got installed. So on a typical Windows 7 machine, there'll be a few hundreds update IDs there. And then the server responds with what new updates there are, if any. What happens next? It does another call to sync updates, but this time it's looking for hardware updates. So essentially, it sends a list of all the hardware and all the driver versions and so on that it's got. And again, the server responds and says either you're up to date or actually there's some new drivers that you need to install. So the responses from the server contain a bit of metadata about the updates. So it contains the update IDs and also some metadata that lets the PC decide whether it needs to or wants to install those updates. So for the updates that the client does want to install, it does a call to get extended update info. And with this, it sends the updates it wants to install, and the server responds with a whole bunch more metadata about where to download the files from and how to install them and so on. So we're going to look at a bit more detail in the actual XML now. So this is a sync updates request. I've abbreviated it because normally there's hundreds of IDs in there, but this is literally just a list of IDs, update IDs that it's got installed. The server then responds with any new update IDs. So there's one here. So this is an update ID. Every update has two IDs, don't know why. Bit of metadata, and then because it's XML, there's an XML tag with some XML encoded XML inside of it. Great. Now, I mentioned before that this is all documented on MSDN. Actually, the contents of this XML tag, that's not documented. And actually, that's where the interesting stuff is. So on the next slide, so this is the content of the XML tag, decoded essentially. So this is the update metadata that the server responds with for sync updates. And what's going on here is the update, each update has a GUID as well, so it has two IDs and a GUID, I don't know why. But it lists dependencies, so it says, before you install this update, you must have installed these other ones first. That's in these prerequisites here. And then it's got these applicability rules. And these are checks that the client can do to see if it needs to install the update. So it can specify things like, go and check if these files exist, go and check the versions of these files or DLLs, check registry values, and so on. And there's a kind of Boolean logic there as well, so it can say, you need to have this file and this file, but not this file, and so on. It can get quite involved. So next, once the client's done those checks, it's decided which updates are applicable. It then does a call to get extended update info with a list of IDs that it wants to install. The server responds with this response, and there's kind of two parts here. So at the top, we have each update ID has some more XML inside of an XML tag that's XML encoded, and it's got a list of files. So the files essentially say, these are the files you need to download, these are the hashes of the files. So now we're going to look at the contents of these XML tags. So this is the really important stuff here. So again, this is not documented on MSDN, but this XML here, this describes how to install each update. So once the file is downloaded, what do you do with it? So what's circled at the top here is the handler attribute. And for different types of updates, there are different handlers, and they have different types of XML for them. So this is a CBS handler, which is, I think, for cab files. And then it's got a list of files here. So this relates back to the files in the previous slide here. So essentially it says these particular files are needed for this particular update. And then at the bottom, there's handler-specific data. And that's, we'll take a bit of a closer look at that a bit later on. So what type of update handlers are there? So we did a full update from a kind of blank Windows 7 install. So we saw a ton of XML, a ton of different updates and things like that. And these are the different handlers we found. So there's CBS, which, like I said, is cab files. There's update handlers for Windows drivers, for full Windows installers, and so on. But the one that really stood out to us is command line installation. That sounds quite interesting, I thought. So we took a closer look at that. So this is the XML that's used for command installation. This example is taken from the malicious software removal tool. So that's the thing which kind of gets, you see that every now and then on Windows Update. And essentially what it is, and what a command line installation is it's just a single exe that gets downloaded, it gets run once, and then that's it. So for things like the malicious software removal tool, it's basically fire and forget. It gets downloaded, it gets run, and that's it. But the thing that's kind of really interesting here, which I'll just expand on here, is this handler-specific data for command line installation. And you'll see here there's these attributes that say program. So it says, basically saying, run this executable that you just downloaded. And most importantly, there's some arguments here. So it says, run this program with these arguments. So hopefully by now you're thinking, actually, this has potential. So what can we do with command line installation? So remember, we're talking about the cases where SSL is not being used. We can intercept all this XML, we can inject into it, modify it, and so on. So with a command line installation, we can download and run any Microsoft-signed executable. So it has to be signed by Microsoft. And we can provide arbitrary command line arguments. So this is looking pretty good. And also, the other thing, which we mentioned back at the start, is that updates get installed as system. So this is really privileged stuff happening. So my first thought, once I'd kind of gone through this, was let's download and run command.exe. Simple. Give it some arguments, do whatever we like. But actually, if you look at command.exe, it's not actually signed. In fact, most Windows binaries on a Windows install aren't signed. I don't know why, but they're not, which is kind of annoying. So the next, we had a think, and that's okay. What Windows binaries are signed? What stuff is signed by Microsoft? So we thought of sysinternals. So this is great. Microsoft bought sysinternals years ago. They're basically tools that are great for hacking, and Microsoft has gone and signed them. Brilliant. So let's use psexec. So psexec is normally used as like a command line tool. You use it to authenticate to a remote machine and run some commands. But you can also just run psexec on the local machine, kind of without specifying any credentials, and just run arbitrary commands from the command line. Brilliant. So here's the plan. We're going to have a man-in-the-middle proxy, essentially, that's going to be intercepting the traffic between the client and the server. And this is what we're going to do. So the client is going to check for updates. It's going to do a sync updates request, and we're just going to pass that straight through to the server. The server will respond and say either there's updates or there's no updates, but we're going to modify that response and we're going to inject our own request. So we're going to inject a fake update, essentially. So the client will say, yes, I would like to install that fake update, please. Give me more information. Now, we're not going to pass that through to the server because that update doesn't exist. The server's going to go, I don't know what you're talking about. So we're just going to make our own response to that. So we're going to respond and say, do this command line installation thing, go and download psexec from me, and go and run that with these arguments. So the client will do that, download it, run it, and hopefully this will work. And this is, so this, we took the XML from the malicious software removal tool, and then we used it to, we changed it to specify psexec with the arguments we wanted. And this is what we had. So this probably all sounds very simple. Modify the XML, psexec, done. This took a while to get working. The theory was very simple, but we spent a long time waiting for updates to happen and tweaking the XML to get it right because it's not fully documented and so on. So we were pretty pleased when we got to this stage. Okay, so now it's demo time. So I'm just going to explain the setup we've got here. So we have a Windows Server 2012 VM that's got WSUS installed and set up. No SSL, which is kind of the default. I've got a Linux VM, which we're going to use to do the modification of the XML. And I'm going to boot up a Windows 8 VM, which is going to be our target. So the first scenario we're going to look at is a local privesc. So the scenario here is that we are a non-privileged user that's got access to a machine, like a typical corporate desktop machine. And what we're going to do is we're going to modify the proxy settings. So we're going to assume, some environments are going to be really locked down. You can't modify proxy settings at all. Some you can. We're going to assume that we can modify the proxy settings. So let's see. Right, so first of all, I'm just going to do, nothing's changed, I'm just going to check for updates. It's going to talk to the WSUS server, the actual WSUS server, and it should say there's not any updates. So, no updates. So there's no funny business going on. Now, we're going to modify the proxy settings. So now this is pointing the proxy settings to my Linux VM. It could equally just be we could point at a local host if we had if we could run an executable, just a non-privileged executable on here, and it would work just the same. So if we check for updates again, hopefully, I spent a long time. Oh, that's because I forgot to run my proxy. Right, so let's run my proxy. Yeah, so this is basically a Python script. It's about 200 lines. It's very basic. It just modifies the necessary request, injects a bit of XML, and let's try it again. Yep, we've got an update. Let's install it. Fingers crossed. There we go. So let's just in case you don't believe me, so we're now running as NT Authority system. Thank you. Okay, so we were pretty pleased when we got that working. That was quite good. So that's a local privesc. So that's kind of the first step. Now there are a few problems with this. So we're talking about a corporate environment. Now psexec is often picked up by AVs as an evil hacking tool. So using psexec, maybe that's not the most realistic thing. So it may get blocked if we try and use that, essentially. So we had to think, okay, what else can we use? So this brought us to another sysinternals tool, bginfo. Now, bginfo, if you're not familiar with it, essentially it displays system information on the desktop background. And actually, it's often used on enterprise machines to let admins tell one machine from another, and so on. Now, probably what you don't know about bginfo is you can specify various different custom fields. And one thing you can do is specify a VB script file to execute to produce an output that will display on the desktop. So again, we can run arbitrary code via a Microsoft-signed binary. And also, the other important thing is we can load the config file, so you can create a bginfo config file, we can load it from a network share. So this is the kind of thing we want to run. We want to run bginfo, we're going to specify a share, an unauthenticated share hosted on an attacker VM, and we're going to tell it to run this file and launch our VB script. Okay, so demo 2 time. Right. So I'm going to modify a proxy slightly. So bginfo is going to be served up. So the scenario now is that we're going to do it purely network-based. So we're assuming we've got no access to any Windows machines, we've got no credentials, nothing. The only thing we have is access to the kind of the Windows network. So I'm going to use a tool called Responder from Spider Labs. And what this does, we're using it to do a WPAD injection attack. So essentially what happens is machines will kind of call out to the network, say, is there any net proxy auto configuration out there? And we're going to respond and say, yes, you need to talk to my proxy. So if I boot up my VM again, so this time we've got a netcat listener. Okay, so we don't need the... The ideal here is we're not got any access at all. I'm going to cheat slightly because normally what would happen is that the machine would periodically check for updates every so often, and then it would download the updates, and at a designated time of day, it would automatically install the updates. We haven't really got time to wait around for a few hours for that, so I'm just going to trigger them manually. But this would all happen. This would all happen automatically if we were patient enough. Right, so when I ran this before, the update, this didn't work the first time, but it did work the second time. So we'll see. We got this working just yesterday, this demo, so we'll see how it goes. I spent so much of my life waiting for these updates to happen. Oh. Come on. Right, so that didn't work, but I knew it wasn't going to work. I don't know why. In theory it should, but there's something weird with my setup. I don't really know. So I'm just going to check for updates again. So fingers crossed this time. There we go. So this has popped up here, and there we go, system again. So that probably all looked fairly straightforward, but the really kind of important thing here is we started off with basically nothing. We just, we're on the local network, but we have no privileges, nothing like that. And we can fully compromise, so not to get code running, we can get code running at system of any machine on the network that's using Windows Update, or WSUS rather, with no HTTPS. So that's what can happen if you're not using HTTPS. So for those of you who do pen tests or audits or manage networks and so on, you'll be asking, okay, how can we check for this? How can we see if I'm vulnerable? So it's pretty easy. Just check this registry key. So this one here, W server, has the URL of the WSUS server. If that URL starts with HTTP and not HTTPS, then you've got problems. And you can also check it by group policy as well. So how do you fix this? Well, like I said, Microsoft does recommend using SSL. They have a guide for it. So basically, go and read the guide. It's just a case of deploying a cert and installing it. And if you're using SSL, it will mitigate the attacks I've just shown. They won't be possible. So just to summarize, so we looked at the drivers on Windows Update. So we found a large number of third-party drivers that can increase the attack surface of a Windows machine. So that's interesting, but for the enterprise, which is what we're focused on, it's not so much of an issue, basically because the updates, the admin has to approve the updates. So for drivers, they're only going to probably just approve certain drivers that they need for their environment, and in terms of widely applicable attacks, there's not a lot there. So that brings us to the unencrypted WSUS. So we've shown local privesc, full local network compromise, basically because SSL is not on by default. So the question now is this really a problem? Do all admins follow the hardening guidelines? I'm going to go out on a limb and say no, not all admins probably follow the hardening guidelines, and certainly in our experience, that's, we've seen that as well. So that's it. Before I finish, I just want to thank these guys who work from Text, and they helped us get this all ready in time. So big thanks to those guys. And just before I finish, the question we started off with: why is Windows Update so slow? We spent a few months looking at this. We've gone into some great depth with Windows Update, and to be honest, we have no idea. Sorry. So that's it. The white paper. So if you want to know more about this, there's a lot more detail in our white paper, which you can go to that URL now and get that. We've got a fully worked example of the XML you need to inject and everything to create fake updates. Any questions? Yes.
Please.
Did you do any testing against the SCCM configure because it's using WSUS backend?
Do we do testing against SCCM? No, we didn't.
Great. Well, thank you very much, everyone. And sorry there was so much XML.
Hang on.